Welcome on in, people. How we doing? I got that stream link up a little late, so we're gonna chill for a little bit. I only got 13 of you guys in here, which one of you guys is me, so that's 12 are in here. We need 7 more. But yeah. What's up, people? How we doing out there? 2 more days to go. It's Thursday. Thursday's one of my favorite days of the week because you know why? It means Friday's tomorrow. And you know what's after that? It's the weekend, which is pretty cool. Yes, we're all here now. What is up, people? You guys like my new house here? Just outside of LA. It's not bad. Didn't like the beach house too much. Hans likes it for sure. A lot of land out here. It's nice. But today's lesson, people, is very, very important. We're going to begin to start graphing our cost curves. In the cost curves that we graph today, you will basically slap onto every graph that we learn about for the rest of the class, for the most part, at least the market structures. All right, so take it as like we're beginning to learn about the ADAS model. That's the level of importance today. Now, obviously, you know, we'll learn more tomorrow as well, and then obviously the next time, like 3 weeks is going to go by, where we're definitely going to revisit this, right? We're definitely going to go back and revisit it a lot, but basically, you're going to get taught like twice because it's important. Mr. Moore, do you know if teachers are allowed to hold students accountable grade-wise for submitting work outside of their 3-week block? They can't. It's a good question. They cannot. They can assign. They can give out work and like tell you to like do it, but you can't be punished in any sort of way. In other words, they can't like test you on it later. They can't grade it for credit or no credit or like anything like that. To my knowledge, I'm like 95% sure, but maybe I'm wrong. But I'm pretty sure. The wildfires. I got a little fire going on over here. It's pretty good. It's pretty nice here. But I would say no. And if teachers are allowed to do that, you better believe I'm about to give you guys a bunch of work. Nice. Why? Is someone trying that? I think so. I don't know. I'm not 100% sure. I shouldn't speak on it if I'm not 100% sure, but I'm pretty sure we're not supposed to. Okay, so some big announcements today. First announcement is 3.1's due. Again, some of you guys keep turning your problem sets in late, and you know what's kind of weird? I don't know how I set it up on Google Classroom, but I get push notifications on my phone. Some of you guys are turning in, well, one is just like annoying to see like late work being turned in on my phone. Like I'm trying to like turn off from teaching and like, you know, live my life that I'm living. But, oh, I gotcha. Some of you guys are turning in problem sets at like 3 in the morning. Like, and I'm getting a push notification. Now, obviously, I live my life on Do Not Disturb, but what is going on? Get your problem sets done. What's going on? All right, so 3.1's due tonight. The Unit 2 test is due Friday night at midnight. And people, there is no leeway in this, okay? Generally, problem sets, I might tack a little bit off there and I still accept it. If you turn your tests in after Friday night, I don't know what to tell you. You've had 3 nights to do it, okay? Oh, gosh. But yeah, so make sure you turn your test in Friday night. Now, some of you guys have already done it, actually, and you guys are doing awesome. Not only on that, but the AP Classroom MCs, you guys are doing awesome. It's crazy. In macro as well, like I really just looked at macro a lot. Here's the results in macro right now. You got to hear this. 22 students took the AP Classroom MCs. Of those 22, 18 of them would have got a 5. They got like 15 out of 16 questions right, like just an insane amount. A few of them got a 4, and like one of them would have got like a 3 or 2 borderline. It's pretty crazy, right? I know we don't like learning virtual, but we're making the most out of it, I think. We're doing pretty good. So I expect the same from you guys. And your AP Classroom MCs have been pretty good and really good. And some of you guys are already taking the test, which is good. Some of you guys only have like a couple questions to do, and like, you know, you skip some. I like that. But make sure the whole point is make sure you take your time on that test and you turn it in Friday night. This is your summative grade. This is the only thing I have for your summative grade on this 3-week stretch. I'm a little bit behind in problem set grading, I think, but it's easy because I know if you turn it in late or whatever, so I can just go there and do all that. Just know that your grade is going to be totally final by Sunday night. Like, it's going to be updated by Sunday night, okay? And then we're going to do problem set 3.2 today. It shouldn't be too crazy. And problem set 3.2 is due tomorrow. And I'm not going to assign you another problem set tomorrow. And we're learning about the same stuff tomorrow as well. So I would recommend this today. Don't finish the whole problem set today unless you just want to be done with it, right? At least do half the problem set and then maybe save the other half for tomorrow. Okay, don't feel rushed to do it. But again, with that being said, don't procrastinate. Just do it all tomorrow. All right, I'm not going to give you another problem set tomorrow. We're going to go deeper into this stuff, and maybe it'll help you a little bit more on that problem set. And also make sure you check problem set 2.9. I put that up really late yesterday. I apologize for that. But that one's really important. That is the last FRQ practice. The last Unit 2 FRQs you're going to see until you take the AP test. Outside of a potential final exam, right? But that's it. So, make sure you check your answers and, fix what needs to be fixed. Okay, people. You've seen the red there. It says, things you need to know after today. I can calculate and graph fixed cost, variable cost, total cost, average fixed cost, average variable cost, average total cost, and marginal cost. Can't stress how important this is. One, to be able to calculate those numbers, right? If given a table or, just some information that pertains to it, and being able to graph it out and understand why the curves look the way they do, and the relationships between all these different costs. So important. People, I almost would say this, and it's not 100% true, but it's pretty true. I'll go out on a limb and say, if you understand how to do this, what's in the red here, and we're going to spend a decent amount of time on it, and you just have a little bit of knowledge of everything else, you should be locked in for a 3 on this AP test. That's how much you're going to see these concepts, how many questions are going to go with this. It's so much. So make sure you pay attention and make sure you're tracking on this stuff. All right. Any other announcements? Oh, yeah, your attendance. Your attendance in the chat today. The attendance is your favorite place to eat locally, right? It could be like Grand Blanc, Fenton, Flint, somewhere I can drive to, like 15 minutes away sort of thing. Where's your favorite place to eat? It could be dine-in, it could be takeout, it could be drive-through. If you're hungry and you haven't had that food recently, what are you craving? Like what is good? What's your favorite? Like your birthday, where are you trying to go? What's your favorite food? Okay? That's your attendance in the chat today. And I might do another attendance in the chat because my macro kids, some were dipping out, I thought. I was losing some kids towards the end. But yeah, anyway. So I think we are we good to go? I think we're good to go. Okay, let's get into it. Cool. All right. So cost of production and perfect competition. So yesterday, let's revisit yesterday a little bit. Yesterday, we talked about production, right? And you guys learned about the concept of the law of diminishing marginal returns. Not the law of diminishing marginal utility, the law of diminishing marginal returns. And the law of diminishing marginal returns states the more variable resources you add to a fixed resource, you're eventually going to start experiencing diminishing returns, right? Things get too crowded. If you keep adding students to a desk, right, eventually they're not going to be able to make widgets. You keep adding workers to a fast food restaurant, eventually those workers can't move around. So that's the idea. So we graphed a couple things. We graphed marginal product, total product, and average product, right? How the average amount produced. We looked at the marginal product, the additional product produced for each added input, and the total product. Now what we're going to do today is we're going to associate cost with those graphs, right? Think about yesterday's simulation. We didn't really do a simulation, but it's really important. I'm going to reference it a lot. That's why it's important. Imagine if every time students made a widget, I had to pay you for labor. I had to pay you for you had to pay me. Whoever was in charge was paying for the labor. You had to pay for the renting the desk. You had to pay for the stapler. You had to pay every time you use a staple, right? Every time you used a piece of paper. If that's what we're going to do today is what would the cost curves look like, with those production curves. All right, now we're just going to add cost to it. That's all we're doing today. All right, let me get to some of this here. Actually, hold on, people. Let's go to the beach house for this. All right, because you guys can see your own you kind of can't, but Sagano's. Hey, that's in Fenton. You can't be coming out here to Fenton. What are you doing? Right, that's where I live. Students aren't allowed over here. Leo's for sure. Witties? I don't know what Witties is. Mara, what's Witties? What kind of food do they make? What's good there? El Potrero? That sounds pretty good. Ooh, my favorite restaurant might be Cancun and Fenton. Cancun and Fenton might be my favorite. Nuevo Vallarta. So Cancun, the management that left Nuevo Vallarta is at Cancun now, right? So that's why I like Cancun a lot. Ciganos, Leos are Five Guys. Tyler, Tyler, are we friends? Cancun? Again, you guys can't be coming out to Fenton though. That's why I live here, to get away from you guys. You know, I like you guys, but gotta keep some distance a little bit. Leos goes crazy. Cracker Barrel. Ciganos. Five Guys. Cigano. Man, you guys like Ciganos. No one's saying Ichiban. You guys got to go out to Brighton and go to Sushi Zen in Brighton. That place is pretty good. There's some good sushi restaurants also in Novi. Five Guys was goated. Man, you guys like Five Guys a lot. What's so cool about Five Guys? I've had it before too, but Jersey Mike's totally not because I work there. Leo, Mr. Moore, you cannot gatekeep Fenton. I can. It's a seafood restaurant in Davison. Wow. Now, okay, hold on here. You know how far Davison is from the nearest ocean? Think about that. I don't know how fresh that seafood is, but I hear you. Merritt. I love seafood. That's like my favorite food. Like calamari. Oh, calamari. Bangkok peppers and Fenton. I like all of Bangkok peppers. Yeah, that's where Caleb worked, right? What Cam said. Ichiban gang. Bangkok, Ichiban's trash. Oh, whoa, shots fired. Ooh, that's going to upset some people. Hey, people, I would eat sushi at a gas station. Sushi is good wherever. I don't even care. I'll go to Kroger and get sushi. I love sushi. All right, anyway, let's move on here. Okay, let's get back to what we got to do. Ichiban is pretty bad. It's not the best, but like, if you're like, Mr. Moore, like, I have Ichiban, would you like some? I would have been like, yeah, I'll take some. Yeah, for sure. It's sushi, right? Okay, so what we're going to try to do, the end game is this. That's our goal, is for you guys to be able to understand why those per unit cost curves right there look the way that they do. And if I give you the graph, you'd be able to calculate and turn those into totals. Some of you guys are like, Mr. Moore, what the heck are you even saying right now? Don't worry. Hey, I said sushi was whack when I was little. When I was like, your age in high school. I didn't start eating sushi until senior year of college. Now, definitely by far is my favorite food. And I used to be a really picky eater. And I still kind of am, but sushi is, it's what the kids say, goated. All right. Okay, so I told you I was going to give you this formally today. Here it is. What is the difference between short run and long run? I talked about it yesterday. And again, remember, like, how important was short run and long run in macroeconomics? When it was placed at the end of a question, it changed everything, right? Long run, short run. It's going to be the same in this class. If it says short run, a long run, you better know what short run and long run means, all right? So it says we will look at both short run and long run production curves. Short run is not a specific amount of time. It kind of was a macro, not really. It's more so the idea that wages are fixed in the short run and then become flexible in the long run. So it kind of was like this time idea. It kind of is with this too, but short run in microeconomics means at least one resource is fixed. And you guys learned about fixed resources yesterday. A fixed resource is a resource that you don't need more of in order to produce more units of output. So in that simulation yesterday, when we're producing widgets, I would have gave students one desk, one stapler, and one pair of scissors. That is it, right? And they were able to produce 3 widgets with 1 worker and 20 widgets with like 4 workers. Going from 3 widgets to 20 widgets, did they need more desks, scissors, and staplers? I mean, it would have helped, but like, no, they were able to produce more with the same amount of resources. So that's the idea of a fixed resource. So if we're in the short run, we're living in the short run, that means that there is one fixed resource there. There's one fixed resource prevalent, right? Like, it'd be, if we wanted to graph Domino's production capability in Fenton, right? There's a Domino's in Fenton. I like going there a lot. You're not allowed, okay? I'm gatekeeping it. And we wanted to graph like how much pizza they can make in a given day. It's short run. Why? Because we're graphing their production and they have fixed resources, right? The building is a fixed resource. The amount of ovens they have is a fixed resource. That's the idea of short run. It's like a snapshot in time. How much can they produce? and there's fixed resources. Long run is this. Underdeveloped taste palates. Nina, preach. Anyway, long run is this idea. Long run is a longer period of time graphene production where businesses would have the ability to change their plant size, right? Like if I said, let's graph out the production of Domino's Pizza in Fenton. Again, it's not a time period, but like over the next 5 years, right? If in the next 5 years Domino's makes another restaurant, like Fenton grows that much where there's 2 Domino's in Fenton, that would be long run. Why? Because now they change their fixed resource, right? Like maybe they have a bigger building, it's still one building, or maybe they have 2 buildings now. So that resource in itself has changed. The building has changed. Maybe they get new ovens, right? Or they get more ovens. Whenever you change the fixed resource, it then makes it long run, right? So it would take a lot of time to do so, but that's the idea of long run. All right, so you guys are gonna get a couple questions on your prompts today. It says like, which of these is a long run idea or a short run idea? Long run is like you change the fixed resource. Like a farmer cut down a bunch of trees and made his land bigger, right? His farm bigger. That's long run. Short run would be like the farmer has his land, he didn't change anything, and like how much stuff can he produce, like given the fertilizer and all that he adds to it. That's short run. Okay? You guys are still talking about food. Yeah, you better be paying attention out there. Okay, so that's the idea. Short run versus long run. Long run, no fixed resources. Short run, there is a fixed resource. We're going to spend 90% of time in short run. We'll spend like a day or two in long run. Okay? Okay. All right, people. Let's go outside to my beach here. All right, so it says different economic cost here. All right, and these were all the costs that I put on the chalkboard there of things you need to know. You need to be able to calculate it. You need to be able to graph it. And you need to be able to like go from both numbers to the graph and graph to the numbers. Okay? There's 2 different costs. There's total cost and there's per unit cost. Super important that you understand the difference between total and per unit cost. A total cost is we're adding all the costs of those resources in that category together. So, for example, total fixed costs. What is a fixed cost? A fixed cost stems from the cost of your fixed resources. So from yesterday, the simulation, it would be the cost of the desk, the cost of the stapler, and the cost of the scissors, right? Because those were resources that we didn't need more of in order to produce more, right? Those are resources that didn't change as we changed production. So the cost of those, so say the desk was 10, the stapler was 5, the scissors were 5, the total fixed cost would be $20. That's the idea. Just add up all the costs of whatever resource we're looking at fixed. In that case, it would be $20. Total variable cost would be what is the cost of, so say we produce 20 units, what is the cost of all the staples, all the paper, and all the laborers that we need in order to produce those 20 units? Add those all up, our total would be the total cost of the variable resources. And then, in order to get total cost, it's like the total of the total, you would add fixed, right? You'd add fixed plus variable. So fixed plus variable equals total cost. What's the cost of your fixed resources? What's the cost of your variable resources? That's gonna be your the sum and equal your total cost. Per unit cost is this. It's different. What we're trying to explore is what is the average cost or the additional cost of each unit. All right. So it would be like this. When we produce 20 widgets, what is the average cost of each widget when we produce 20 widgets, right? So maybe it's like $2, right? Would be the average fixed cost, right? Well, okay, it would be like this. I just said the total fixed cost was 20, and if we produce 20 units, the average cost of each unit would be $1 then. That's the idea of average fixed cost. When we produce said number of units, what is the average cost, in only looking at fixed cost, of each unit? That's average fixed cost. Same with variable, right? You're going to take your total variable cost minus or divided by output. What is the average cost of each unit when we produce some said number of units? And then average total cost would be average fixed plus average variable, right? What is the average total cost of each unit when we produce X amount of units? And then marginal cost, obviously, is what is the cost of each additional unit of output? When we produce that 20th hat, what was the added cost when we went from the 19th hat to the 20th hat? What was that additional cost from producing that additional unit? Okay? All right. So here's your formal definitions. Again, fixed costs that do not change with the amount that you produce. All right, so like in real life, that would be like building rent, right? Like your rent's locked in. It's like $1,500 a month, $1,500 a month, $1,500 a month. Like if you're a business, insurance rates stay the same. It's like here's your total amount, and then like divided by 12, right? Manager, like any sort of salary, like my salary is a fixed cost to the school. It doesn't matter like how many lessons I provide or whatever I do in terms of teaching. Like I'm gonna get paid the same amount no matter what, right? That's the idea of a fixed cost. So average fixed cost would be take your total fixed cost divided by the total quantity, right? And then we're going to get what is the average cost of each unit. The average fixed cost of each unit, right? Because we're only looking at fixed cost here. That's the idea. Variable cost is resources that do change as you produce more. So variable cost would always increase as you produce more output. It is a cost that changes as you produce more. So, what does that look like? Raw materials, labor, electricity, right? If I'm a business, I gotta spend more money on pizza sauce and pepperonis and cheese and things like that as I make more pizza. I gotta spend more money on more workers if I want to make more pizza. If I have my workers, work longer hours to produce more output, I gotta pay more for electricity. Those are variable costs. So average variable costs would just be like average fixed costs. We're just gonna look at variable costs. It'd be your total variable costs divided by your total quantity, your total product, and that'd be your average variable cost per each unit produced, right? Like, when we produce 20 hats, each hat on average cost how much, right? Would be the idea of that in terms of variable cost, like $2 maybe, I don't know, right? So yeah, if we produced 20 hats, right, and the total variable cost was $40, then it'd be $2 a hat would be the average variable cost. 40 over 20. I think I remember those numbers. All right, so then total cost is just fixed plus variable. So average total cost would be your total cost divided by total output. Or you can also do average total cost as AVC plus AFC, average variable plus average fixed. And then lastly, your marginal cost is the change in total cost over the change in output, okay? Generally, the change in output's 1, right? Like in most problems you're going to get, it's like when we produce the 4th hat, what was the additional cost of producing that additional hat, the 4th hat? But sometimes it might look like this. It might say, if the production of two more units of output increases total cost from $100 to $120, the marginal cost of each additional unit of output was 10, right? The change in total cost is 20, but we looked at it from like the 10th hat to the 12th hat, right? So when we added those 2 additional hats, each additional hat costs us an additional $10. So sometimes it might be like that. It's rare to see it like that. Because most of you guys, if I didn't put the answer there, it would have been like 20. That was the change in total cost. But we added 2 units of output here. So like, what is the additional cost of producing each additional output? We went from 10 units to 12 units, sort of thing. But generally, it's like when we produce that 5th hat from the 4th hat, what was the change in total cost? So it's like it'd be 20 over 1, 20. Okay. So marginal cost is the change in total cost over the change in quantity. But generally, the change in quantity is going to be 1. We're going from one unit to the next. So your denominator is going to be a unit of 1. All right. This is a big moment for you guys. Big moment for your AP micro careers here. Big moment. It's high stakes. Will you become an econ guru? If you're not an econ guru already, if you get a 5 this year, you're an econ guru in my heart. Okay. This is big time. So what you see here on the left is our per unit cost. Or sorry, Mr. Moore. What you see in the black here, this is our total cost, and then these are our per unit cost. All right. So generally, you're going to be given some total cost, but it could be anywhere. They could give you per unit cost, and then you got to identify total cost. You given total cost, you got to identify per unit cost. So let's do it. Let's just fill in the missing values. So when we produce 0 units of output, notice this, and it's a very important concept. If we produce no output, the variable cost is always $0. It has to be. Like imagine if we were adding up the cost of the paper and the staples and the labor yesterday in our simulation, and we didn't produce any widgets, there'd be no cost. We didn't use any staples, we didn't use any paper, and we didn't use any workers. So variable cost is always $0 at 0 units of output. So if variable cost is 0 and our total cost is 10, how much is our fixed cost? It has to be 10. Variable cost plus fixed cost equals total cost, so like fixed cost has to be 10. Now generally they give you fixed costs, and I need to change this so I do that. They'll say 0 units of output and the fixed cost is 10. Well, if your fixed cost is 10 for 0 units of output, it's got to be 10 for all of them. A fixed cost does not change as you produce more units of output. So once I identify my fixed cost, I can fill it in for everything. It'd be 10 for every unit. If the fixed resource doesn't change as you produce more, the cost of that resource would not change either. So a fixed cost will stay $10 for all of them. So now that I have my $10, right, I can add up everything else, right? So like if I know the fixed cost is 10 here, I'll take 27 minus 10, that's 17. The cost of the variable resources needed to produce 2 units of output would be 17. 17 plus 10 is 27. Here I know my fixed cost is 10. 35 minus 10 is 25. The variable cost of 3 units in total is 25. Right, so there's all of our total cost. I hope that's easy. Like again, what does this mean? 5 units of output, what is the total cost of all of our variable resources? $60. What is the total cost of all of our fixed resources? $10. Our total cost would be all of our variable resources and all of our fixed resources. The cost of those added together would be 70. That's our total cost. It's generally pretty easy. Marginal cost is the change in total cost over the change in output. Now notice the change in output is going to be 1 here. So that makes it kind of easy. You can simply just look at the change in total cost. This would be 10. This would be 7. Right? This right here would be 8. Right here. When we produced this 4th hat, cost went up 15. The 4th hat additionally cost 15. Right? When we go from here to here, right, when we produce that 5th hat, total cost goes up by 20. The additional cost of this additional hat is 20. When you go from 5 to 6, the additional cost of that 6th hat is, in this case, 50. All right, that's the idea of marginal cost. The change in total cost over the change in output. So each unit of output additionally costs how much additional more dollars. Okay, that's marginal cost. Notice something, people. Some of you guys are really smart. Some of you guys already noticed it, perhaps. You guys learned yesterday about the law of diminishing marginal returns. The first couple workers we add, they get more and more productive, and then eventually they start stepping on each other's toes, and eventually we get less marginal product and less total product, right? Total product becomes, marginal product becomes negative, total product begins to go down. So if we associate costs there, you should see that eventually we're going to get to it. So the first couple workers we hire, they're going to be able to produce output at a lower and lower cost because they're specializing, and then eventually, right, it's going to get more and more costly to produce an additional unit of output because our workers become less and less productive. I know some of you guys are tracking on that, and I appreciate you. All right, we got a per unit cost over here. We got AVC, which is average variable cost. We got AFC, which is average fixed cost. We got ATC, which is average total cost. Okay? All you simply do is take whatever cost you're looking at. So if I'm looking at average variable cost, I'm going to go look at variable cost over here, and I divide it by quantity. So like 0 over 0 is like that, right? 10 over 1 is 10. Oops, go back. All right? This would be 17 over 2 would be this value. 25 over 3 would be here, right? So let's fill some in real quick. So this is easy numbers here. The average variable cost, this is what average variable cost means. What is the average cost of each unit? When we produce 4 units? It's $10. If we produce 4 units, and the total cost of producing those 4 units in terms of variable cost is $40. Each unit had to have cost, on average, $10. That's all that simply means. It's not that hard. It's not rocket science. This is econ science. It's easy, right? When we produce 5 units, it costs $60 in total in variable. So each unit has to cost $12 on average. 12 times 5 equals 60. So imagine this, right? Imagine if they give you AVC, you're not given VC. Would you be able to calculate VC? Yeah, you just take your average times the quantity. If on average, when we produce 5 units, it costs 12, in total, 12 times 5, because each one costs 12, and there's 5 of them, it equals $60. On a scale from 1 to 5, 1, you are lost. 5, you're feeling pretty confident. How are you feeling on this material? Throw it in the chat. That's your second sentence for the day. All right, average fixed cost. 5 being awesome, 1 like you're scared right now, okay? Average fixed costs would work the same, right? Now if we're looking at average fixed costs, we're going to look at our fixed costs. Oops, stop doing that, Mr. Moore. and we're going to divide it by output. If our total fixed cost for 3 units of output is $10, what is the cost on average for each unit when we produce 3 units, right? It'd be 10 over 3, which is 3.3 repeating. Yes. Tyler put a 6. Nice. 5, 5, 5, 5, 5, 5, 5. Wow, people. Are you just saying that? Are you just saying that? I don't know. I think you're just saying that. All right, anyway. Average total cost, again, will work the same. But there's a cheat to it, right? And there'll also be another cheat over here. Like, this is the point where, like, it should be really easy. A cat in the box. Because, like, it's math, right? You can recheck it in so many different ways. ATC has to be AVC plus AFC added together, right? That's one way to calculate it, right? And maybe those are the values you get. And you're not given any of these values over here, then you're expected to know if AVC is this, AFC is this, you're expected to know, like, that's ATC. You add those together. Or, right, you know, the average total cost of 6 units, each unit, right? If the total cost is $120, we produce 6 of them. The cost of each unit on average is $20. Again, we can flip it the other way, right? The average cost, or the total cost of producing 6 units, if each one costs 20 on average, we made 6 of them. 20 times 6 is 120. Pretty easy, I would say. So yeah, 120 over 6. Add those together. There's so many different ways you can do it. But yeah, notice AVC plus AFC equals ATC, just like VC plus FC equals TC. So yeah, these are the per unit costs. On the left is our total cost. Generally, we only graph our per unit costs. We're only going to be messing around with our per unit costs because we know this. When we get to the point where we're learning about why does a business decide to make 10 hats? Why do they do that, right? We know that businesses, just like people, think marginally, right? They choose to produce 5 hats because the 6th hat costs more than they're going to make, so they choose to make 5 hats, right? The marginal revenue from the 5th hat or the 6th hat is less than the marginal cost of the 6th hat, right? So we think margin. So we're always going to be using averages per unit. We want to look at what is the average cost per unit and what is the additional cost of each unit. We don't really care about total cost, right? But, you know, you have to be able to go from one to the other. So, like I said, we're going to graph our per unit cost, and this is our per unit cost graphed out here, right? Here's what, you know, our curves will look like if we put this information and we put it in here. Very, very important. Now, some of you guys are like, oh, like, you know, like that looks like a lot of graphing. That looks like a lot of work to, like, you know, like there's a lot going on here. People, these cost curves are always going to look the same because it's all about relationships, okay? The relationship between marginal costs and averages, right? And I'm going to talk about it here in a second, but basically just know this. Your cost curves have to look like this. You have to draw it like this every single time. So step 1 is this. Marginal cost is always U-shaped. Why is marginal cost always U-shaped? I'm going to talk about more here in detail in a second, but just for now, look at this. Marginal cost goes down, and then it goes back up. It is related to marginal product from yesterday. Marginal product went up as we specialized, and then eventually it subsides. It goes down. The law of diminishing marginal returns. So the first couple of units, it gets cheaper and cheaper to produce each additional unit, and then eventually the law of diminishing marginal return sets in. It's going to get more and more costly to produce more and more units because each worker gets less and less productive. So with that being said, marginal cost always has to go down to back up. That's the idea. It gets less costly as you produce the first few units of output, and then eventually to squeeze out more units of output is going to get more and more costly because workers are less productive. Marginal cost is what you draw first, every time. Always draw a marginal cost first, all right? So if you're doing your notebook, just draw it up. Don't even put numbers, draw a U-shape. The next curve that I like to put in is average fix. Average fix has to steadily decrease over time, right? If your total cost is $10, no matter how much you produce, the cost of that's going to get spread out as you produce more and more quantity, right? So average fixed cost has to steadily decrease, but it'll never become negative, right? There's probably a math word for that. It's going to get closer and closer to 0, but it's never going to touch, right? What's the math word? I think it's like asymptote or something like that. It has to get closer, but there's always going to be some sort of dollar value, right? You can't, you know, even if you produce like 1 million units, right? It's just going to get spread out and spread out. So average fixed cost always steadily decreases over time. Okay? The next one is average variable and average total, right? Average variable and average total have to do something very, very important. It always has to cross your marginal cost curve at its minimum point. And we kind of talked about why yesterday a little bit, right? It's like If the average on the test is an 80%, and then we have test dodgers, we have people making up the test after the test, and the student that makes it up afterwards is, the average is 80%, the student that makes it up gets an 85%. If the marginal, the additional, is greater than the average, it's always going to pull up the average. If the average on the test is 80% and someone makes it up and gets a 75%, obviously that would pull the average down. So it doesn't matter if marginal cost is increasing or decreasing. It's all about, is it greater or less than the average? If it's greater, it's going to pull the average up, and if it's less, it's going to pull the average down. Again, think about it like this. If the average on the test is an 80%, my first test dodger gets a 75%. That's going to lower the average, right? And then, say the next test dodger does better, though. They get a 78%. Although, right, our marginal is going up, right? We went from 75 to 78%, right? For graphing the marginal, the additional, it's still going to pull the average down until we have a student that gets above an 80%, or the new average, right? At that point, we need like an 85% to pull the average up. So that's the relationship always between marginal and average. They try to trick you all the time. I'm going to try to do the same thing, right? It'll say marginal's decreasing. What has to happen to average? We don't know. It's all about, is marginal greater or less than the average? Then we know. So yeah, it doesn't matter if marginal is going up or down, right? Is it greater or less than? That's how it relates to the averages, right? Then the last one is average total cost. Same idea, right? So that's the marginal cost at its minimum point. However, we know that right? We know average fixed cost plus average variable cost equals average total cost. And we know that average fixed cost steadily, gets closer and closer to zero but never touches. So these vertical distances have to be equal to one another, right? The distance between AFC and zero has to be the distance between ATC and ABC. Because again, AFC plus AVC equals ATC, right? Like this distance here has to be equal to this distance here. This distance here has to be equal to this distance here, which is kind of not here. I drew it poorly, but that's the idea. If AFC steadily goes down over time and AFC plus AVC equals ATC, AVC and ATC have to keep getting closer and closer, but again, never cross, never touch, right? Cool. That's the idea. So you guys are like, Mr. Moore, that's a lot. People, once you draw it a few times, it's going to be the easiest thing in the world, right? Draw marginal cost first. Average fixed cost just goes down the whole time. Start at the same point. Average variable, start at the same point, right? Crosses at marginal cost at its minimum point. ATC, draw it up because AFC plus ABC equals ATC. Gets closer and closer and closer, but never touches. But still also crosses at its minimum point. Mr. Moore, it's really hard. No, it's not. You got this. You got this. You got this. You got this. Now in class, what I usually do at this time is like I black out the screen. And you got to draw it, right? I hope at some point today you draw it. You try. And then the next time you try. We basically do it for 4 days straight in a row as a warm-up. You can't use your notes. And then I closely look at each one. Oh no, I'm blurry again. But yeah, that's the idea. You're not going to get better at this unless you draw it. You're not just going to be like, oh, I think I get it. And then be able to replicate it. You got to practice it. Okay? Sometimes this works if I do this. Okay. So, calculate total cost, variable cost, and fixed cost for the fifth unit. Let's do a little practice question here. So we generally graph per unit cost, and since we graph per unit cost, we should be able to identify total cost, right? So let's do it. The fifth unit, what is the total cost, variable cost, and fixed cost? So all you got to do is at the fifth unit, draw a line going up. That looks like it's diagonal almost a little bit. And where does it hit each of your cost curves? If I'm trying to calculate total cost, I'm gonna use my average total cost curve, just like I would if I was using the table and I'm trying to figure out the missing value of total cost in a table. It'd be the same idea. The average total cost states this. Here, give me those. The average total cost. Carefully pay attention. Listen to me. The average total cost is $14. The cost of each unit produced is $14 when we produce 5 units. So if we produce 5 units of output, the cost of each unit of output is $14. So if we produce 5, each one costs $14. 5 times 14 is, I don't know. Do the math real quick. But it'd also be the area of that, right? It'd be 14 times 5, so it'd be the rectangle there. That'd be the area of your total cost. If the total cost of one unit output is 20, wouldn't the marginal cost of it also be 20 and not 10? What you mean? What you mean? The total cost for one. So as we go from 0 to 1, the marginal cost would be 20. Because, oh yeah. The marginal cost would be less. Yeah. So you're saying start marginal cost less than total, right? Yeah. But yeah, that's right. Assuming your fixed cost is 10, right? If your fixed cost is 10 and the total cost of producing 1 unit of output is 20, the variable cost was 10, and the additional cost of going from 0 units to the second unit is additionally 10. Wait. Yeah. Look at the graph. Well, if fixed cost is 10, well, so look at this. If our average fixed cost of 1 unit of output is 10, right, that means our total fixed cost is 10 for all of them, right? If our total fixed cost is 10, the cost of the first additional unit of output would have to be, oh yeah, you're saying would have to be 20 because the variable cost would also be 10. I think, right? Yeah, so your marginal cost has to start up higher. The reason it's not a big deal is because it's not a big deal sort of thing. There's a couple things they're going to look at. They don't really care about where you started at. Marginal cost has to be U-shaped. AVC and ATC have to cross it at its minimum point, and AFC has to decrease over time. And again, the vertical distances have to be the same. So I think you're talking about like how come I didn't start marginal cost up higher? I think. Yeah. It needs to start at 20 is what you're saying. Wait, no. But we're gonna have to look at this again. I don't want to waste too much time on it. Okay, if the total cost, if fixed cost is 10, and variable cost is 10, the total cost of producing 0 units output was 10, and the total cost of producing 2 units of output would be 20. So the additional cost of going from 10 to 20 is 10. So this is right. We'll look at it here in a bit. All right. Okay. Anyway, average variable cost would be like this. All right. Average variable cost would be, you look at your ABC, or your total variable cost would be, look at your ABC, and again, what does it mean? It means if we produce 5 units of output, the cost of each unit of output on average is 12 for variable cost. If each unit on average costs 12 times 5, the total variable cost would be 12 times 5, whatever that is, right? This one's really important, actually, because generally this is going to occur. Generally, average fixed cost will not be present. You're not going to see it if you're given a graph. And at some point, we're going to begin not to draw AFC once we know what it would look like, because we don't need AFC. And here's the reason why we don't need AFC and KFC. No, I'm just kidding. Is this: if our average fixed cost of each unit of output when we produce 5 units of output is 2, our total fixed cost would be 10, right? Can you see this? If I got rid of AFC, because we know total fixed cost doesn't change the more you produce, so it doesn't really matter which unit of output it is. The average fixed cost of 3 units of output would be the same as the total fixed cost of 3 units of output would be the same total fixed cost of 5 units. Okay, yeah, I think the graph's correct. We'll do it here in a bit. My mind's going 100 miles an hour. But notice this, right? This area right here. What the heck, Mr. Moore? This area right here is equal to the area of this right here. If we know that AFC is the difference between ATC and AVC, we don't need AFC on our graph. If we needed to calculate the average fixed cost of 5 units of output and this was gone, right? We know that the average fixed cost of the 5th unit of output is 2, right? Because this is the distance between ATC and AVC. So the average fixed cost of 5 units of output is $2. And then if we know it's $2 when we produce 5 units of output, 2 times 5 is 10. So we don't need AFC on our graph. So just be aware of that. You're going to get questions where this is gone, and they're still going to ask you to calculate AFC, and they're still going to ask you to calculate FC. Okay? All right. Lastly, total cost curves. Total cost curves are going to look something like this. We'll stop right here. Total cost curves, we don't usually graph our total cost curves, but make sure you understand what they would look like. If we're graphing total fixed cost, it's constant. It doesn't change. It's $10 no matter how much we produce, right? Variable cost would obviously increase the more and more we need, and then total cost would be parallel to variable cost because fixed cost is constant and fixed plus variable equals total cost. That's what our total cost curves would look like if we actually graphed it out. Okay? I think we're just gonna stop right there. We don't need to do too much because we're gonna review this anyway. I plan on getting through this, but we'll just do that tomorrow. And I promise you, I won't lecture a lot tomorrow. I want to hang out with you guys a little bit before we gotta say goodbye. Okay. All right. So let's. I'm gonna drop the 3.2 problem set. Hang out with me for a good 15 minutes. If you want to go take a 5-minute break, that's fine. Be back at 1:50, and then I'll release you guys right at 2 o'clock. And if you need more time, you can stay, and I'll help you out with your problem set. No asking about test questions though. Okay, don't do that, right? Because I don't want to accidentally give any answers out in Google Meet. All right. If you got questions about like a test question, Jupiter message me. Okay. All right. So people, I will see you in Google Meet